Right, from the top of a 50-metre high bridge, two boats are seen at anchor. One boat is south of the bridge but 50 degrees west. The other and has an angle of depression of 38 degrees, so you're looking down on it. The other boat is south 60 degrees east and has a 35 degree angle of depression. Right, how far apart are the boats? Well, what happened there? I lost my image. Question 3D. Right. Let's move this over here. Right, so we need to get these boats. We need, you see, if you're on the pier, right, we're on the pier, and it's going to be a right angle triangle when you're on the pier, right? This is us on the pier here. This is the water, and it's 50 meters from the pier down to the water. And looking at this boat out here, it has an angle of depression of 38 degrees. So, what's that angle going to be? The angle of depression, yeah. So, not a straight line really, but anyway, angle of depression, you see, if you're looking straight out from the pier, you're looking out this way, right? Say you're at Rathmullen, you're looking across at the far bank, you're looking straight across. But then if you're looking down at this boat, the angle of depression, from here to here, you have to look down, your head has to turn down through 38 degrees to look down at the boat. Okay, so what we're trying to do is figure out the distance, the straight line distance between the bottom of the pier, where we're standing, the bottom of the pier though, and the boat, right? Here's the boat here. So that's 38 degrees. This line out here looking across horizontally, and this one, the water, they're parallel. So this 38 is also, it means that this angle here is going to be 38 degrees. And from the point of view of the boat, this 50 meters is the opposite. This is a right angle triangle. So we can say that's the opposite, and so this here is the adjacent. So tan 38 degrees equals the opposite divided by the adjacent, 50 divided by the adjacent, right? Multiply both sides by the adjacent, and we get adjacent, whatever that distance is, multiplied by tan 38 degrees equals 50. And we're looking for the length of the adjacent. So if we divide both sides now of this equation here by tan 38, we get adjacent equals 50 divided by tan 38 degrees. Right, so we'll bang that into the calculator using the fraction key. 50 over tan 38, and I get 63.997. So let's call that 64 meters. So the bottom of the pier is 64 meters from boat A. We'll call this one boat A, right? 64 meters. Just going to make some space now, and we'll do a similar procedure, I think, for boat B, for the other boat. Right? So again, standing on the top of the pier, it's like being at the top of a right angle triangle. We're standing on the top of the pier, we're standing here, and the water's down here. Boat B is out here, right? There's boat B, and we're told that it's a 35 degree, so the angle of depression. So we have to avert our gaze downwards by 35 degrees to see the boat. So this means that this angle in here is also 35 degrees. And we still know that the height above from the water is 50 meters. So tan 35 degrees equals opposite over adjacent, 50 over the adjacent. And using similar algebra as the last time, a shortcut would be we just swap the tan 35 and the adjacent, so we'd have the adjacent equals 50 over tan 35, right? And bang that into the calculator. So I'm just going back and editing the last calculation, putting in a 5 instead of the 8 there, and I get 71.41 to 2 decimal places. 71.41 meters. So now if we're looking down, we have the flat distances where we don't have to think about the pier now. We can think about the bottom of the pier, right? Where the pier meets the water, say, this dot here, right? And this is the distance out to boat A, and this is the distance out to boat B, right? And we know that this distance here is 64 meters. We know that this one here is 71.41 meters, and we're looking for this distance here in red, the distance, the straight line distance from A to B. Now what else do we know? Well, you see, looking at this diagram here, we know that the angle between the two boats on the flat, and we know that the angle in here, so this boat is 60 degrees east of south, and the other one is 50 degrees west of south. So they're 110 degrees apart. This angle here is going to be 110 degrees. So we know this side, we know this angle, and we know this side. The only side we don't know is the distance between them. We need to get the distance between them. Alright, I'm going to make space now. We have all our information on our little sketch. Now we're just dealing with a flat triangle on the surface of the water. And in that situation, so here we're dealing with the cosine rule. I've just brought in this clip here from up here from the exam paper, right? These are formulas in the back, and it's the cosine rule we need, because see, these A, B and C, they're small, they're the sides of a triangle, and in our triangle we know the side lengths B and C. We don't know A, right? But we know the angle that corresponds, the opposite angle to A, which is capital A there, right? So I'll switch to black, right? So A squared equals B squared plus C squared minus 2BC cos A. So A is going to be 110 for us, and 64 can be B, 71.41 can be C, and baby A, small a, is the one we don't know. So we can just rewrite this, get the square root of both sides, and A equals the square root of all this stuff, right? B squared plus C squared minus 2 multiplied by B multiplied by C multiplied by cos A. So A equals square root. You can fill it in with the numbers now. 64 squared plus 71.41 squared minus 2 times 64 times 71.41 times the cosine of the angle 110 degrees. And we stick that all into the calculator. So bring up the square root sign, then you have 64 squared plus 71.41 squared minus 2 multiplied, or in brackets, you can use the multiply sign either, multiplied by 64 multiplied by 71.41 multiplied by cosine 110 close bracket press equals, and I get A equals 111 0.00 degrees accurate to 2 decimal places. Or sorry, that's meters. Forget that. That's meters, right? Now, if you wanted to check that, you could draw it out. You could get your protractor out and draw 6.4 centimeters, 7.1 centimeters, angle of 110 between them. See how many centimeters you get between A and B. That would be good practice. So hopefully that's right, or nearabouts right.